and the things that he's involved with. And so I've got an absolutely amazing bio here of what he has done and what he does. And to be honest, I have to confess that some of it's a bit beyond my capabilities of understanding, because it just sounds so impressive. But I do recommend, if anyone wants to find out more of what he's done, that you get hold of this bio, because it really shows what he's been involved with. Richard is the founder of Spatial Days Limited, a company providing mapping and software development services to public and private sector organisations in the UK and elsewhere. He worked for 8 years as an engineering geologist for Jacobs Consulting Engineers, and then joined another company as a GIS consultant, where he worked on many large geoinformation projects in the UK and elsewhere. And then there's some more very important sounding things, which please read those if you would like to. But almost all of Spatial Days projects which he's involved with at the moment are environmental in character and are often undertaken in overseas countries, including Kenya, Ethiopia, Malaysia, etc., Fiji and the Solomon Islands, and several more. And most of Spatial Days' recent project work has involved software development of web mapping applications for the display and use of mapping and satellite data for the environmental sector. I'm glad I didn't get muddled up with that, but as you can tell, he's very knowledgeable and a completely different sort of speaker to what we had last night. But I'm sure, like myself, you will be so riveted by what he has to say. So a very big welcome to you, Richard. I'm delighted that you're here. Thank you very much.
Great, thank you, Hazel. Sorry that was so difficult.
It's because I'm not scientist, I'm the art end, you know.
Yeah, that's great. Okay, I'm just going to share my screen. I've got a PowerPoint that I'm going to take you through. Hopefully you can see that. Can you see that? Is that in presentation mode?
That's good.
Right. Okay. Good. All right. So climate change and its real world impact is Sid's example. And I already wanted to just take you through this presentation just to talk a little bit about the scientific basis for climate change, and then take you through one of our recent projects that kind of showcases what we are trying to do about it. And so I thought you might find this interesting. Hazel's already done some of this intro stuff, which is great. We are a little company. There's only 4 of us. We're based in Aldermaston in Berkshire. And we've worked all over the world in a number of places, and we're looking forward to doing some work in Antigua and Barbuda and some other Commonwealth countries in the next couple of months. So looking forward to that. So really, when it comes to climate change, we're really looking at long-term shifts in temperature and weather patterns on Earth. And we really are looking at long-term shifts. However, as I'm going to show you, our kind of view on this is getting shorter and shorter term as we are busy changing the climate under our feet. These changes in temperature and weather patterns can be natural. So there are a number of natural cycles on Earth, and they can be completely natural, like the variations in the solar cycle, for example, where the sun varies in terms of the amount of sunspots or not over a sort of 11-year period. But since the 1800s, humans are really the main cause of climate change. And that is largely due to the fact that we are burning fossil fuels like there is no tomorrow, to do a bunch of things, but in particular, driving our vehicles, heating our houses, and producing energy, producing electricity. And we are doing this at an alarming rate. And this has led to a real increase in the amount of carbon dioxide and methane in our atmosphere. And these gases are greenhouse gases. And what that means is they effectively act like a blanket around the Earth. So the atmosphere just acts as a kind of insulator, and it traps the sun's heat and keeps it in and raises the ambient temperature of the whole world. And the main sort of emitters of carbon dioxide and methane are the energy sector and the industrial sector, mining companies in particular, and oil and gas, and then the transport sector, obviously, in terms of trains, aeroplanes, and then we heat our houses. We have to heat them, and we have to grow things to eat. We have to raise cattle, for example, and there's a big debate about that. And also we need to use our land appropriately, and all these kinds of changes that we are making and the way we are using our planet are resulting in large CO2 emissions. The greenhouse gas concentrations in our atmosphere are now at higher levels than at any point in the last 2 million years. And I know that on this call, obviously there's a variety of views on this. I'm a geologist, so I have a kind of an old Earth creationist viewpoint. But there's just, we are sitting at the moment in a situation where the carbon dioxide concentrations are higher than ever. And these graphs are a couple of little graphs I wanted to show you, because I could talk about this all night, and there are thousands of scientists all around the world working on the climate change problem, okay? And many of them have devoted their lives to studying this issue. And so condensing all of their research into one little talk in 20 minutes is tricky. So I've decided to do that mostly through the use of graphs and curves, just so you can see what I'm talking about. And this particular graph is really quite instructive. What it shows is going back to 1750 or so, which is about 300 years now, 250 years. Going back that sort of period, we can see that our sort of atmospheric CO2, the amount of carbon dioxide in our atmosphere, was sitting at about 280 parts per million at that kind of point. And gradually over time, there's been a very slight increase up until the sort of 1800s, where the gradient really started to increase. And then round about just after the war, just after the Second World War, the gradient really started to increase exponentially. And after COVID, we are all experts at seeing exponential graphs. We know what they mean. And as a result, you'll notice that these graphs are starting to look exponential. And that's no accident. Also, if we look at the black curve, which is interesting, that's the amount of carbon dioxide we're actually producing in the globe, in the world. And as you can see, it does start off pretty slow. It kind of similar gradient to the amount that's in the air, and then it just really takes off just after the war and just goes crazy. Now the blue curve doesn't really respond to that initially. It carries on going reasonably flat, and that's basically the Earth trying to mop up after us. It's trying to suck up the CO2 that we're producing, but there comes a point around about the 1980s or so where it simply gives up. And so now the amount of CO2 we're producing is roughly the amount of CO2 that ends up in the atmosphere. And those two curves are now pretty much coincident. My dad is a climate change denier, if you like, very passive one, but nevertheless. And he says, well, hang on a sec, these are natural Earth cycles. They go in cycles. So they go up, they go down, and then there's some kind of midpoint in between. So the fact that it's going up means that it's just going to come down at some point, right? And the answer is, well, no. If you look at this curve, which goes back yay further, goes back roughly 900,000 years. And the evidence from this comes from ice cores, which have been drilled in Antarctica and other places, as well as through tree ring studies and dendrochronology. And looking back at the CO2 concentrations, we can see that they do bounce up and down from sort of 800,000 years forward. They're bouncing up and down all the time with an average around about 220 or so. And that's great. You can see there's a cyclic nature to it. It's not a perfect sine wave, but it's pretty close. And then it gets to around about our sort of time frames, which is in the last couple of 100 years. And suddenly things change. It's going up in a little bit of a curve, just like it did before. And then suddenly, round about zero, which is pretty much where we are now, it just becomes like worse than exponential, and it just keeps climbing right up until where that current level indicator is. So we are way beyond any kind of sine wave cyclical situation. We are in uncharted territory. We have pushed this way beyond where we should have, and we're essentially in trouble. As a result of all this greenhouse gases, we have a temperature now on Earth which is about a degree warmer than it was at the turn of the century. And in our last decade, we've just had the warmest decade ever recorded. And so these temperatures are getting worse and worse. And as you can see, these different models, there's 6 of them on this graph, they show a remarkable coincidence in terms of a remarkable agreement, actually, in terms of how we can see the temperature changing with time from the mid-1850s onwards to now. And so the CO2 concentrations and methane concentrations are causing our planet to get warmer and warmer. And that's great, right? Because then we don't have to go to sunny places on holiday. We can just stay where we are. But unfortunately, the Earth is far more complicated than that. We have the whole planet is a set of interrelated systems and cycles. And when you start making very fundamental changes to some cycles, it affects other cycles. And in particular, can start leading to extremes where you get positive reinforcement, negative reinforcement, and you start getting extremes. And when these extremes happen, they become more frequent. And the Met Office has done a study on this, which is shown in this graph over here. And what we can see here is that geophysical events, geological things like volcanoes, earthquakes, that kind of thing, they've been pretty static since the 1980s. It sometimes feels like there's more of them, but there isn't really. We're just getting a bit better at measuring them. And that's pretty static. That's that orange bars. But meteorological events are slowly increasing. And they're getting bigger, and tropical cyclones, for example, are getting stronger. Hydrological events like flooding, those are getting more and more as well. And climatological events, so your sort of droughts and wildfire, although it looks like it's just perched on top of those curves, that orange little bar, if you compare the end of that graph to the beginning, you'll see that it's almost triple. So these kinds of extreme events are happening more and more often. And it's the extreme events that are really dangerous for us. This is a brilliant little diagram that the Met Office produced. And what it shows is in the middle is the causes of our issues, the drivers. So our greenhouse gases, aerosol emissions, and our land use, which isn't always the best. And what that does is it causes a series of impacts. So the impacts are the sort of next circle around, sort of the inner ring. And I'll just run through a bit of those, a couple of those, because they're not always obvious. So the one example I've already discussed is extreme weather. But we also get changes in the water cycle. So where rain used to be, it now is not as often. Where rain used to be a certain amount, it's now way more. So your water cycle is different. The land is warmer and the sea is warmer. The ice caps are melting. The sea level is rising. The amount of carbon dioxide that the oceans are taking up, CO2 reacts with water and forms carbonic acid. And that means that the pH, which is a measure of the acidity of the oceans, is dropping. And organisms in the ocean don't like acidic water. So our oceans are becoming more acid. And the oceans are therefore changing character. So certain ocean water bodies are warmer and colder, and so currents are changing. And so we're having some big effects on this planet, which we don't really understand. And we don't really know what the full consequences of them are. But on the outer ring are all the kinds of impacts that we are experiencing that we do understand. One of them is risk to water supplies. So obviously with increased drought, you have difficulty getting water. You have abundance of water in one place and not enough in another. Localized flooding occurring where we weren't expecting flooding to be. flooding of coastal regions, largely because of sea level rise. Damage to marine ecosystems, that is happening all over the place in terms of coral bleaching and ocean acidification. Therefore, the amount of fisheries that the amount of fish that people are catching is dropping off. And that's simply due to the fish migrating to different areas. And there's a loss of biodiversity, which is an extremely dangerous situation. In many habitats, certain animals are simply disappearing and are ceasing to exist. Our seasons are changing. The summers are merging. Things that used to happen in summer are now happening in winter and vice versa. There's heat stress in many cases where people are really suffering through, really high temperatures. So, in the 35 degrees plus, and that can sometimes lead to heat exhaustion and death. There's migration of pests and diseases. So if you think about things like the Zika virus is spread by mosquitoes. If there's more water around and there's more temperate latitudes because things are warmer, the Zika virus spreads and goes further. So that's just one example of how that would be affected. And then there's damage to infrastructure from floods and from tropical cyclones. And one last one is food insecurity. So it's now becoming interesting in terms of being able to feed our planet. And it is interesting how sensitive we are to that kind of thing. You only need to have a war in Ukraine and suddenly there's a potential food crisis across the globe. And these are real impacts. And the project I'm going to talk about in a little bit of detail goes some way to addressing some of these things, but also goes towards making the countries involved a little bit more resilient to these kinds of effects. And I'll talk about that in a minute. So it's generally agreed now amongst the scientific community that if we can limit our global temperature rise to no more than 1.5 degrees by the end of 2100, it'll help us avoid the worst climate impacts and help us maintain a kind of livable planet. And the reason I put an asterisk there is that case now, in terms of the number of scientists who feel that humans are having a major impact on climate change, is now up at 99.9%, okay, which is a scientific way of saying almost everybody. And it used to be about 97% a few years ago. It's now way up there. So in terms of the backing of the scientific community, the evidence is indisputable. And we've accepted other scientific theories with far less evidence than this. Global warming, unfortunately, at the moment is projected to reach about 3.2 degrees by 2100 if the measures that we have agreed to undertake at the Paris Accord and at COP26 are not actually implemented, and in many cases they're not being implemented. And where this becomes quite interesting from a Christian point of view is that the 100 least emitting countries, in other words, countries that are kind of like the least culprits, generate about 3% of the total emissions. 10 countries with the largest emissions contribute 68%. Okay, and the problem with that is that the people in countries that are creating more of the problem really do have a great responsibility to act first. Telling countries like Fiji, for example, to get their act together from an environmental point of view is hypocritical in the extreme when their contribution is minuscule. And this is where climate justice really comes in. There's a wonderful talk by, I think she's the Prime Minister of Barbados. You can put Prime Minister Barbados talk COP26. If you put that into YouTube, there's an amazing talk that she did at COP26, which is all about climate justice. It will change your views on that forever. She's an incredibly powerful speaker, and it was really quite an emotional appeal, really, to the developing countries, and in particular the countries that emit the most carbon, to change our ways. Okay, so what can we actually do about this? Because there's a lot of doom and gloom here, and unfortunately the doom and gloom is valid. We really do need to make changes, and we need to make adaptations. We've got to address the consequences of climate change, and we've got to protect people. We've got to protect homes, businesses, livelihoods, infrastructure, and the natural world. And if we can put adaptations in place to help us cope with the impacts of climate change, we can deal with current impacts from climate change, but also future impacts. And that will save a huge amount of money. And I know a lot of governments are always wondering how much money they should spend, how much money they should allocate to climate adaptations. But the answer really is that your benefit you get from putting those benefits in place are roughly in the order of tenfold. So they are a really good investment. In particular, systems like early warning systems. We were involved in developing an early warning system for flooding in Malaysia. If you can give early warning systems to people and evacuate people from their homes in advance of a major tropical cyclone, for example, you can really save a huge amount of lives, and you can also get people to batten down the hatches and lose less property, lose less assets. So in addition to changes that you and I can make at an individual level, climate action really requires significant financial investment and will from governments around the world. Climate inaction is vastly more expensive. And the thing with not doing something about climate adaptations is that we can either pay that bill now, which is extremely expensive, or we can pay far more dearly in future. And that's just how things are. So that is the picture from a scientific point of view. What I would say is that there's tons of literature on the subject. And if you're interested in this, please go and read reputable sources. Okay, so there's a lot of disinformation around as well. So please go to reputable sources to read about this and get yourself informed. A good source is the Met Office. Another good source is United Nations. There's a lot of stuff on there. And of course, the IPCC, which is the sort of international panel for climate change. There's a lot of material in there as well, which is all coming from scientific studies that have been peer reviewed. So, the information that they're presenting is not flaky, it's backed by evidence. And I really just appeal to you to always go to sources that are reputable. Be careful what you read and what you believe. Okay, that's really a whistle-stop tour through climate change. I'm sorry it had to be so fast. I now wanted to just talk about the Common Sensing project, which is a project that we've been working on. And the idea of the Common Sensing project was really to use mapping and satellite data to help the countries of Fiji, Vanuatu, and the Solomon Islands to build disaster resilience for them, to help them with food security. And in particular, and this is probably the main point, is to really help them access climate finance. There are many climate funds that have been set up that countries that can access. And you need to justify why you need to access that funding, and you need to justify that it is because of climate change and prove that. And if you can get access to huge amounts of funding. And that funding is there to do climate change mitigation and to help countries cope with the effects of climate change. And the countries that are kind of the most affected by climate change in the world today are what we call SIDS countries. So they're small island developing states. So countries like Fiji, Vanuatu, Antigua, and the Maldives, countries like that. Okay, so they're usually islands or atolls, and one of their sort of real problems is global sea level rise, and that for them is not just it's not just a detail of their lives or anything. It's actually an existential threat. It's going to cause them to cease to exist, and so they're taking the global sea level rise issue very seriously indeed. So we worked with the governments of Fiji and Vanuatu and Solomons and tried to do the best job we could in terms of understanding the need. What are the needs that those countries have? And by doing that, we were able to realized that the best way we could help them was to give them mapping data, give them climate data, and give them decision support tools to help them be able to make decisions about what to do about climate change. And then to train them so that they can use these tools appropriately, use the data appropriately, so that data isn't misused or abused. And to do that, we had to work with a number of partners. These partners are all across the world. The most important partners, I guess, are the United Nations themselves, our own Met Office, the Commonwealth, and my little company as well, at bottom right, and the University of Portsmouth, and also the body called the Catapult, who I'm doing a lot of work with at the moment. And you know, these organizations are worldwide, and we each had a particular responsibility. My company's responsibility was to act as the technical lead to bring all these different technical streams of these different companies together. So to do this project, we had to bring data in from a number of places. A lot of this data is openly available. It is free. You just need to know where to go to get it. And we brought topographic mapping data in, land cover data, climate data, hazard data, so natural hazard data like earthquake data, for example, and windstorm data, and then various different population data sets, so we can understand where people are and work out how vulnerable they would be to climate hazards. And then we created a whole series of data sets as well for the project that we needed to be able to answer various questions. In particular, the satellite data that we've processed. We've used Landsat data. We've used data from a series of satellites based on a program called Copernicus, the Sentinel-1 and Sentinel-2 satellites. And we've put together all that data into a very large archive or data cube. And once that data is all in that data cube, we can then start analyzing that and developing derived products from that data. And I'll show you a couple of examples of those in a minute. Here's a couple of examples of some of the data we've produced for the project. So at top left are data sets like the digital elevation models. So that's really around understanding what the terrain of these different islands is. And if you understand what the terrain is, you can understand how tsunamis are going to impact the coastline, for example. You can understand where landslides are likely to occur. And you can understand where you should be relocating villages, for example. If you have to move them from the coast, where do you put them? And there's no point putting them on really steep slopes, for example, because you're just potentially putting them in the path of another hazard. You also don't want to put them in a floodplain. And so these kinds of digital elevation models are very useful for planners to understand where to put people. The one on the top right is a relative bathymetry data set. So this is looking at how quickly does the seafloor shelve upwards to the coast. If it shelves in a very gentle fashion like that does, as you can see, it's going from a sort of dark blue, which is kind of deep water, through sort of mid blue tones to very light blue. And if that's going through that sort of transition, it's actually a very dangerous scenario for tsunamis, because tsunamis tend to stack up and the wave gets higher and higher as it sees the bottom of the seafloor. It gets higher and higher. So by the time it hits the coast, it's far more destructive because of its height than it used to be. And so relative bathymetry is a really good way of just understanding which parts of the coastline are likely to be more vulnerable to tsunamis than others. Slope steepness is the one on the bottom left. So that's always looking at how steep slopes are and grading them. And so your green slopes are relatively flat. Your more orange and dark orange slopes are really steep. Shoreline extraction, I'll show you some nice examples of that, but that's really understanding how the shoreline along the coast actually varies with time. And the wonderful thing about the satellite archive, particularly the Landsat archive, is it goes back to the 80s. So it really does give us a 40-something year history of how the average shoreline is moving, whether it's going out into the sea where there's deposition happening, or whether it's eroding and sea level rise is causing the land causing the coast to recede. And then bottom right is another product called fractional cover. This product is quite useful to really understand where vegetation, which is green on here, is becoming red. So where is it becoming bare soil? Where is it going from being nice lush vegetation to being cleared ground with nothing on it? And then the blue pixels on there are all the areas where there's urban development. And so we can see how urban development is changing with time, and trying to understand urbanization and other more sort of social problems that these countries have. We have a variety of tools. I won't go through these, but we have a variety of tools that we've developed. Some of them are out of the box and others we've developed ourselves, just to help our users really try to get value out of these data sets and enable them to support the kinds of government policy decisions that they're going to need to make to adapt and cope with climate change. I was going to do a little demo, but yeah, maybe I should. How are we doing for time? Yeah, okay. Let me do a quick demo. I hate doing demos, so if I can avoid them, I usually do. They never work properly, but I'll try. Okay, can you see that? Hopefully you can see something called the Common Sensing Open Portal. Is that visible to everyone? Yes, okay, great. All right, so what this is an example of one of the services that we've put together. It's available on a website called Common Sensing if you're interested in that, commonsensing.org.uk. And you can go in here and read about the project and read about all the things that we've been doing. And one of the places you can go to is Solutions and Data, and that brings you to this page here. And what this page is really doing is bringing together the various little apps and various tools that we've put together for this project, and putting them all together in one place, putting them under some user management so we know who's logging in and who's using them for what. And bring them all together so that people can access these and make use of them. And the one I really wanted to highlight, there's a lot here. I won't go to all of them. Some of them are quite technical, but this one here is quite an interesting one, which is all about the data cube. So this is called our data cube on demand. In here is a whole host of different products. So and what you can do is you can use satellite data to generate products that show you different things. So for example, the shoreline extraction product, you can go in here and you can pick the place that you want to analyze. So let's say you wanted to look at this bit of Fiji. This is Fiji, by the way. This is the main island of Fiji, the secondary island of Fiji, and then all these other tiny islands are also part of Fiji. And you might decide that you want to look at how this shoreline has been changing with time, for example. So you can pick that area and you can say, right, I want to look at that from 2017 through to today. I want to use the Sentinel-2 satellite to do that. I want a resolution of 10 meters, which is the size of the pixels on the ground. I want a particular coordinate system. And I want the tidal range, and I can set these parameters, set those parameters, and then submit. And when you do that, you get a product coming out the end, which looks a bit like this. So it'll actually show you where the shoreline was in 2017, where it is in 2018, where it is in 2019, et cetera, et cetera. So that'll help you really understand that in this area, the shoreline is changing, whereas in this area, it's pretty static. So that allows you to then start planning where you're going to put your development, where you're going to move people, for example. You don't want to move them into a place where active coastal erosion is taking place. So these products are really there to help underpin various government policies and government decisions that these governments can make as a result of climate change. And so I just wanted to show you some real examples there. Okay, let me just jump back to this. Okay, so I brought just thought some really practical examples now, just to show you how some of these products actually look. This product here is for a place called Sigatoka, which is a tiny little village on the coast of Fiji. And this image really shows us that a lot of vegetation is green. It all looks great. It's very happy. But along the coast, we've got these purple bits. And these purple bits are areas where the soil, the land used to be covered in vegetation, and now it's bright purple. It's become bare soil, and there must be a reason for that. And when you zoom into this area and have a look, this area is covered by coastal dunes, so that makes sense. You won't see any vegetation there. It's just sand. But the weird thing is that on this side of the river, there's some purple pixels here, and that's strange. There shouldn't really be anything there. This should just be vegetation. It should be fine. And when we went and analyzed this in a bit of detail, we discovered that there's a Chinese company here who are dredging this river mouth. And what they've done is dredged all the sediment out and chucked it onto the plants. And here's an example of them doing that. This is from the Fiji News website. And they're busy pouring out all the silt on these trees, and these trees don't like it very much, as you can see from this picture down here. And as a result, they've died. This is now bare soil, and the satellite now sees it as bare soil. So, you know, when we actually see something in our satellite imagery, these products can actually really tell us what is going on. And if you didn't know that that was happening, you'd be able to use your satellite to actually find out what's happening, and then go there and figure out what's happening and potentially stop it before environmental impacts can get any worse. Also in this area is an example of our shoreline product. So this is really showing all these little lines that are in different colors are really showing how the coastline is changing over time. And we can see this is a very dynamic river mouth. It's changing a lot. And the interesting thing here is that this is where the river mouth used to be, and now it's eroding out like so. Now, someone might say, oh, that's because of climate change. And it's well, not really. No, that's just a normal geological process. But these products are really useful to help our governments understand what to do with government policy and decide where to put things, where to build things, where to put defense measures in place. Okay, and here's another little example of a little village in Fiji called Baretu. And this is the little village of Baretu over here. And what they're finding is that they used to get flooded every now and then, probably on a sort of once in 10 years, once in 20 years type cycle. Now it's happening every single year. And they really wanted some help to know what to do. And so we looked at various satellite products that we could use to help them. And we used this product. And this product shows a series of red pixels. So the red pixels are where land is being created. So there used to be water there, and now it's land. And the green pixels are indications of where something that used to be land, but now it's water. And as you can see on the inner banks of rivers, we get deposition. So the river's depositing sediment. So all your pixels are red. And on the outer bank, we're getting erosion, which is where all the green pixels are. And no surprise in this sort of situation, where this little village is, most of the pixels here are green. So what that means is that this is an active a river shore that is actively being eroded. And it's logical, they're on the outside of a riverbank. This village is just not positioned very well. If they moved to a different place, they wouldn't be in this position. This shows us our shoreline products. This shows the same kind of pattern. So your white lines here are your older satellite images. So it shows you the shoreline used to be there, and the more recent ones are red. And this is where they are now. And that pattern is borne out here. And we haven't got the most recent data in, but you can see where that shoreline is now. So this whole village is just being eroded away. The question is that due to climate change, or is that just due to the fact that this is just a normal river bend and that's what rivers do? And the answer in this case is, well, there is a climate change effect happening here as well, but this is just a normal river morphology situation. We then looked at a different satellite product called water permanency. So what that does is it looks at a pixel on the ground and says, how much of the year is this pixel covered by water? And if it's covered by water a lot, it'll be a very solid yellow pixel. And if it's covered by water less often, it will be these sort of little gray tones. And what we can see is that in 2016, roughly, when this image was taken, the river was actually at a real low point. There were lots of pixels here which are not bright yellow. So that indicates that the water was much lower. There was less water in this river. Whereas now in 2019, when this image was taken, the river is basically solid yellow, which basically shows how much more water there is in this river here than then. And then this is an example of one of the climate tools that we've built for them. So we've taken a number of these different climate models that go back some 30 years. And you can then pick the climate parameter you want to look at, whether it's total temperature or precipitation, and you can then see how that's varying with time. The red line at the top is the maximum that it's ever been in that time period. The minimum one is the one at the bottom, and the average is somewhere in between. And actually in this area, for this particular village of Barreto, there is a steady increase in the average annual rainfall. So it does really look as if Barreto as a village is being flooded more often due to climate change and not just to natural processes. So with that kind of information and with that kind of backup, that village will now be able to make a climate finance application and say, guys, we need money to help us to stop being flooded. And what we want to do is build a breakwater or build a flood defense or whatever. And we need $200 million to do that. And then they can access the climate finance funds and get the protection they need. Also part of the project has been a lot of capacity building. So we've done a lot of training and a lot of capacity building for the people in these countries, mainly the government, people in the various government departments. But there are a number of NGOs and other organizations that we've trained as well and have come along to our training courses. And most of the time, it's just getting people familiar with the data, helping them understand how they can make best use of the data. And we're coming up with there's another training trip, which I'm planning for early December, which is just in time because we're supposed to be handing over this project at the end of December. And handing it over to the Fijians, the Vanuatuan government, and the government of the Solomon Islands to then take forward. And once after December, we then fall back to a kind of third line support role and just support them the next few years while they take these tools forward and do more, hopefully more exciting things with them than we've been able to do. Okay, and now there's some time for some questions, which hopefully we've got time for. But yeah, I'd love to take questions from anyone. And yeah, I'll hand over back to you, Earl or Hazel.
I'll just say, Richard, I've not had any come through. So if we want to use that feature we used yesterday, if you have a question, want to raise your hand, using the reactions button down on the bottom of your screen here in Zoom. And then you could call on people, Richard, that might be easiest. I do have a couple questions if no one else does. So
okay,
let's let that be for a moment.
I hope I haven't intimidated you all.
Shall I ask a couple?
Yep.
Yeah.
Go ahead.
So 2 questions. One, we know there are deniers out there. I'm sure that they certainly exist, that climate change isn't a real thing and it's not something that has actually been caused or whatever. Based on all the scientific data you shared, plus what we read all the time, so we heard last night from Ruth, how is it that people can honestly still say, nah, this is just a cyclical thing, or it's not really something to worry about? That's one question. And then the other was, we saw an example of what you've done here in Fiji, Vanuatu, and Solomon Islands. Are all countries no matter who they are and where they are, doing the same thing, knowing that wherever they are in the world, they're in trouble.
Yeah, okay, well, thanks. So I think for the first one, it's a really difficult question to answer. What I would say is that definitely in the last few years, as far as I'm concerned, that there is a huge amount of skepticism amongst people generally towards government and towards institutions. Many of us have been misled many times about various government policies, about various things, and as a result, it just harms the credibility of politicians. And so, when it really comes to these kinds of things, and a politician stands up and says, "We should do X," there's just an innate sort of skepticism in people thinking, "Yeah, really?" And I think that really kind of feeds into this whole thing, the sort of anti-establishment, anti-institutional sort of viewpoints, and that's essentially why people who are anti-establishment have started coming to power. We've had Donald Trump, for example, in the States, and that kind of thing. He really came to power because he was an anti-establishment figure, and people like to doubt things. They like to talk about conspiracy theories. It's fun. What they don't realize is that on the end of this are people who are going to die, and by the end of 2100, we're looking at between 1 meter and 2 meters of global sea level rise. Okay, so yeah, that's a lot, and the problem with sea level rise is you don't just lose coastline, you don't just lose your low-lying areas, you don't just lose people to tsunamis and storm surges and floods, coastal flooding, but what also happens are things you don't really understand, which is that people who live there need to move. They need to move somewhere else, which creates all kinds of social difficulties and problems. And also, there's other things as well, like salt water, for example, from the sea starts intruding into groundwater. So all the groundwater that used to be pumped out and then irrigated, used to irrigate the crops, can't be used anymore because it just kills everything. So, just that kind of thing has an impact. So even a tiny variation of global sea level rise in the vertical direction has a big horizontal effect. And on particularly countries like Fiji, the amount of sort of flat land is limited anyway, because it is quite mountainous. So there are only so many options where you can move people. And if you're also trying to contribute to your gross domestic product by growing products like sugar, for example, sugar needs to grow on slopes that aren't over a certain slope. So suddenly, your global sea level rise is suddenly affecting food security because these people haven't got enough food. And so, you get these weird effects which you would never have thought of. And we heard a little bit from Ruth last night from that lady in Zimbabwe who was talking about, climate change and domestic violence. There's correlations between these things you would never have expected. So, yeah, I would say there is a kind of anti-establishment feeling. Yeah, but to me, the evidence is overwhelming that we are really messing this planet up. And you don't really need to look for longer than 5 minutes on Google through reputable sources and scientific journals to see that, the evidence is just overwhelming. So, yeah, I hope that goes some way to answering that question. Yeah, it's a bit philosophical.
So. I believe Andrew has a question for us. Andrew, do you have a question?
Yeah, no, I do have a question. Thank you all. I just couldn't find the mute button. Richard, thank you. I mean, it was a very technical talk, and I really appreciated it. But my question is sort of somewhat personal, I guess. And even in what you said just then, there's a sort of how do you feel about this whole thing question. I mean, you took us for we begin with a very large picture of what's been going on, and then you're dealing on a very small scale, with all due respect to the Pacific Islanders, and very practical and very. I mean, I guess you get some sense of, yes, we can do something useful here, in this very limited, very technical way. But how do you feel about everything that sort of goes on between those two extremes? Are you feeling that this is worth doing, even though these larger developments are so massive and so beyond anything that we can really manage? I mean, how do you feel about it? Are you pessimistic? Are you optimistic? And are we? I mean, I guess I would attach another question there from the church's point of view. Are we missing something in this sort of how we are grasping the reality of this?
Mm. Okay, I'd say I'm optimistic, actually. I'm optimistic because, you know, things like COVID have really demonstrated that when the world can come together and put aside all our difficulties and our ideologies and all our problems, we can actually vaccinate, you know, huge chunks of the world, for example, when we get our act together and when we cross over issues like who's going to pay for it, and, you know, how is this going to be funded, and how's this going to happen? When we can act as a coordinated group of countries, then stuff can happen. And COVID demonstrated that. And, you know, I think that's an abject lesson for all of us, that, you know, when governments cooperate, you can accomplish great things. So I guess I'm optimistic from that point of view. I just wish that people would see climate change as something as serious as COVID. And, you know, it really is an existential crisis for some of these islands. I heard a rumor, which is just an urban rumor. I haven't looked into whether it's true or not, so feel free to do so. But one of the countries in the Pacific, I think it's Kiribati, have bought a large tract of land in Australia. And they've done that because they may need to relocate their entire population. You know, so when it comes to these island nations, they are not joking about climate change. They are really on the sharp end. We've been helping Fiji with a number of projects that they have, and one of them is a village relocation project. So they are literally moving villages as we speak from the coast where they used to be and moving them inland to safe areas. And it's traumatic for the people. They don't want to move. Their ancestors are buried in that village. They don't want to go anywhere. And, you know, the government is saying, look, we are really trying to save your lives here. And, you know, so the sort of climate change denier type lobby is really unhelpful in those cases, because, you know, they can then say, well, hang on a second, how do you know this is all real? You know, it's like, well, when it's flooded your house, it's too late. You know, we want to move you before. And so, yeah, these are real sharp end issues. So I'd say I'm optimistic. I think the world can cooperate on these things. I think we need to take climate change seriously and regard it as an emergency of the level of COVID, in fact, way worse. Even if we could get it to the level of COVID, I'd be happy, I think. And then the other thing that really does give me a lot of optimism is in the field of scientific advance. You know, we do have the capability to develop technologies to help us through this. And really taking a leaf out of David Attenborough's book, you know, one of the things he was saying is, yes, we need this measure. Yes, we need that measure. Yes, we need that measure. Yes, we need that invention. Yes, we need all of them, because we are in that level of crisis where any contribution is a good thing. And so, you know, I'm optimistic from that point of view. I think there's a lot of things that science can bring to the table to address climate change and a number of other environmental issues. And yeah, we need to support all of them. Yes, and all of them, because we've gone long past the point where we can pick and choose. We are no longer we no longer have that option.
Chris, I see that you have your hand raised. I have another question here on my mobile, but I also recognize it is our break time. So what I suggest is we take our break, and then Richard, if we come back and have a couple questions before we hear from Rachel and John. Can you hold on to your question, Chris? Is that okay? Okay, does that sound okay, Hazel?
Great, thank you.
Yeah, so I think we'll do that.
Yeah, that's brilliant.
So we'll come back for 15 minutes, so 8:45. With a couple questions, then we'll pass it on.
Great.
Thank you.